All right, everyone. So today, today we are starting incredibly late, probably the latest that we've gone so far. This might be a world record. I think today we might genuinely be completing this at 4 in the morning. Um, as if no one can tell by now, I am like the most. I am like very much a night owl. Apparently, I just can't work in the daytime. Um, I just work at night. That's just when I work. I do my best work at night, I guess. Um, my best work, and I'll be like half asleep during these. But anyways, let's pull up our lo-fi music. Let's get right into this. I'm gonna try to see if we could speed through these reviews. We're gonna do some psych so we can get through it a little faster. Um, Tomorrow, like I really want to be able to do these um with more time and with an energized brain. Um, it just doesn't tend to happen, but we gonna get there eventually. Maybe one day in some future. Maybe not. Maybe not exactly the nearby future, but a future for sure. Okay, here we go. Yesterday the lo-fi was pretty low, so let's make it hi-fi today. Um, I think that's a little better at least. We'll bring it up a little bit. It should be calm. It's not like maybe okay, maybe a little lower than that. But I think that's probably good. You should be able to hear my voice. Everything is calm, chill, cool, calm, collected. That's when our watch says. Um uh I don't remember his name. That's why I'm not giving him creds. Um okay. So uh is when the subject perceived the signal when there was none present, false alarm. Uh, Negative and positive one half. So everything before carbon can have less than an octet, and everything further, every, like periods 3 plus can have more than 8. Ionizable at low pH, ionizable tends to be protonated. The Not very long. Chiral, filled with inside back area of the eye filled with inside back area of the eye filled with cones. Oh man, man, I had to click again. That hurt me. Is a combination of the suspensory the ciliary body. Contextual effects. How does one calculate the energy required to promote an electron from one energy level to another? Um, E is equal to HF, or is equal to HC divided by wavelength, which is equal to the negative Rydberg's constant, parentheses 1 over ni squared minus 1 over nf squared, close parentheses, where Rydberg's constant is 2.18 times 10 to the negative 18th joules per electron. Boom. Square main function, extra a muscle attachment point and extra layer of protection for the eyeball. The absolute threshold of sensation. Um, Such a way so as to achieve a noble gas configuration is the neurotransmission processing. Vitreous humor provide like create pressure and provide nutrients to the back of the eyeball. Um, let's go. States that the mind perceives objects as being symmetrical or symmetry. We'll do rows. The energy level of the valence electrons. Non-adapting. In what direction does electronegativity go? It goes toward fluorine. So Y equals X. Iris is a muscle. What is a residue? It's a an individual amino acid. What do groups allow us to easily ascertain the number of valence electrons? Top down uses background knowledge, which is driven by theory. What is the molecular geometry associated with two bonded pairs and zero lone pairs? Linear. Conjunctiva. The number of protons. Special case must you remember when considering ionization energy. If they have a full like octet, they're like the the ionization energy jumps massively. The amount of energy needed to remove an electron. At high pH, ionizable groups tend to be deprotonated. Conscious sensory experience of neural processing, perception. Do all compounds with internal electronegativity have dipole moments? No, they can be symmetrical. Say set continuity between metals and nonmetals. London dispersion forces always be greater. Group one, transduction gives a negative response to a present signal, a miss. Sigma bond, where metals found in the periodic table. They're found on the left and middle. What is the periodic trend for atomic radius? As you move from left to right, it's going to decrease. So it's increasing in the reverse of like y equals x, but not going toward the positive side, going toward the negative, going toward negative x instead of like the arrow's pointing like this. How do you determine the number of valence electrons an atom has? The group number. Yes, that's the same thing. Sense of depth. How do you calculate the atomic weight of an atom with two naturally occurring isotopes? Um, percent frequency times their mass number. In upregulation of sight, our pupils blink, our pupils dilate and begin to synthesize light sensitive molecules. Completely covered in cones. It creates pressure in the front of the eyeball, and it also provides nutrients to the iris and the cornea. Wait. Okay, cool. Where are the halogens? Group 17. Dipole-dipole interactions are attraction forces due to opposite partial charges. These are permanent dipoles within the molecule. Um, yeah, pretty much. A similar provides a sense of balance and I don't know. That wasn't me yawning. I don't know. Like I want to say linear acceleration and head positioning. Yeah, I always confuse those two cards. Like always. Like I confused them before too. Is a monocular cue where objects are perceived as being closer when they're in front of something. Um, being closer when they're in front of something. Interposition. Where are the noble gases? Group 18. What are the possible values for n? All positive integers besides zero. They need to be obviously whole numbers. How does one determine whether an atom's ion will be larger or smaller? If it's a metal, it's going to be smaller. If it's a non-metal, it's going to be bigger. What is a period in regards to the periodic table? It's a row. What is the third quantum number? The magnetic quantum number, or ML. What are the general characteristics of nonmetals? They're brittle. They have no luster, and they're poor conductors of heat and electricity. Okay, that was kind of right, but I didn't say the gases part. So what's the difference in less than 0.5? What is the tetrahedral? Nociception. Ciliary muscle driven by data. The lens. Always saying no unless you're 100% sure that the signal is present. Bottom up processing. Electron affinity is Y equals X. Symbol for strength, D prime. Absolute, this is experience, expectation, motivation, and alertness. Space filled with aqueous humor in the front of the eye. The anterior chamber. This is the law of past experiences. It basically says that past experience dictates the way that you interpret something. It kind of like takes priority. So you're gonna have like if you have like an L and an I together, like you're gonna know that there's two separate letters rather than combining them into one. You basically just learn. That's kind of what that's saying. What is Vesper theory? It's a Vesper theory is used to predict the shape of a molecule based on its non-bonding and bonding electrons in its Lewis structure. What is an orbital? It's a region of space where an electron is likely to be found. What is bond length? The average distance between two nuclei in a bond. What are the general so it's malleable and ductile. Number one. It's lustrous, solid with high melting points, and they are what's it called? And they're good conductors of heat and electricity. The pupil's main function is to um, the pupil's main function is to contract and dilate to modulate the amount of light entering the eyeball. It is the special part of the macula. States that objects grouped together are seen as a whole closure. Iris behind the iris, area behind the iris to the back of the lens, the posterior chamber. Just notice the threshold at which you're able to notice a change in sensation. When a subject gives a negative answer for no correct rejection, suspensory ligaments. The number of electrons, protons, neutrons, and Zeph increase. Processing into a perception. Phobia. Group 2. Increases. Vitreous chamber. Fast adapting. Dipole. What are two types of covalent and ionic? What was information? Okay, now we're starting to get into one that might take me a second. So it's going to reduce the amount of DNA. It's going to stabilize proteins. It's gonna induce cooperativity and it's going to bring catalytic sites together. Wow, that was actually kind of smooth. What kind of bonds make up a double bond and what kind of each? Uh, a sigma and a pi bond. What? The pi bond is perpendicular. That's the angle at which it's most stable. Um, like at which the molecule is most stable configuration. Okay, what are the general characteristics of metalloids? They have no general characteristics. It's like they have distinct characteristics, some that are attributed to metals and some to nonmetals. Retina filled with photoreceptors. What kind of bonds make up a triple bond? It's one sigma bond and two bonds that are perpendicular to the bond's axis. Fire at the beginning of the stimulus and calm down after a while. Um, Slow adapting uses inductive reasoning and is always correct. What is the ionization on y equals x? Gestalt principles. What is electron affinity? Electron affinity is the, let's see, what is electron affinity? Um, Electron affinity is gonna be, uh, hold up, let me see something. Okay. Um, so, right. So, what is electron affinity? Electron affinity is the, ooh, this is the amount of energy used in order to pull an electron, right? The amount of energy, um, the amount of energy released when an electron, when it gets an extra electron. Yeah, that was like really hard. The iris's main function is to contract and dilate the pupil. Um, uh, just to contract and dilate the pupil. It's to um, control the size of the pupil. I guess I don't know. Yeah, I was just kind of confused on the wording, but I think that's right, pretty much. Gestalt's principle states that our brains recognize fragments. What is a photon? It is a massless particle-like and wave-like packet of electromagnetic energy. What is electronegativity? Electronegativity is the amount of force used in order to pull on an electron. I didn't say in a bond. That is true. I did not say in a bond. What is a two bonded pair is bent? Sigma. It is a catalog of the photons that are released by an electron and they like falling from the excited state. What is the effective nuclear charge? Zeph is going to be equal to the number of protons minus the number of shielding electrons. It provides the sense of um, um, it provides a sense of um, I haven't even done any cards, bro. It provides the sense of this no the sense of it's spatial orientation, right? And then what is the balance? Just balance and spatial orientation. Okay. I'll give myself hard because realistically, I'm not going to get that the next time. I'll be honest. What is a valence electron? It's just an electron on the outermost shell. Um, you get a pi bond because it has an amino and it has an acid. To be honest. The vestibular system. Where are nonmetals found on the periodic table? On the right side. What are general characteristics? So they're brittle, they lack luster, um, they might be gases, and they are poor conductors of heat and electricity. Often more than one. Uh, the ciliary body, the mass number, the cornea. Covalent bonds are generally formed between Covalent bonds are generally formed between two nonmetals. These are temporary forces caused by electron density shifting between the atom. So it's a temporary dipole that forms, and therefore a temporary attraction that forms from like dipoles being formed. Is the opening the pupil. What is electronegativity? That is the amount of force used to pull in an electron in a bond. A sense of balance and spatial orientation. Okay. All right. 4% done. We literally go up by like 1% every day. But realistically, okay, we're gonna do a little something because I hadn't done this before, but it'll give us an actual like better sense of what percent through it where we actually are, because I'm not gonna lie, I am not doing like all of these cards that I'm gonna show you, uh all of all of these cards that they said they didn't use, I'm not using them either. Like, I think the creator of this deck, he did really well. I'm honestly gonna trust it. I'm gonna trust it. I'm gonna trust the deck. I'm a lot of people say you learn best from you learn best from the practice itself. And they don't even really want you to dedicate as much time as I'm probably gonna dedicate on content review. So we'll see. Like no one's like people are not supposed to be dedicating this much time to it. But I am gonna do it just because I just want to do it. I just want to do it right. So yeah. So hold up. Let me suspend those cards. I'm just gonna literally suspend everything in this deck. Um, there shouldn't be any in this. Um, all right. Now that we've done that, let's see how far through the deck we actually are, bruh, bruh. Okay. So essentially, we are. How in the world is it that I just suspended 1,300 cards and I'm still 4% through? You gotta be lying, bro. You have to be lying. We're gonna do this math for ourselves. Hold up, cause it's dead ass about to be 3 in the morning, and this shit is getting me tight. Um, what is that? What do you even mean, bro? That I've done 286 cards, and you're trying to tell me that it's only been a couple days, so I'm bugging a little bit. But okay, well, the math is indeed correct. Okay, that literally didn't help at all. 1,300 cards. It takes 1,300 cards to get me 1%. Apparently, I don't know. I don't know. I don't know. I guess if you take out 1,300 cards somehow, it's still I'm still only 1% better than I was. Um, Damn. Maybe I should have waited until I needed an uplift. Uh, okay. So, um, honestly, today's gonna be another 50 day. Okay, today's gonna be another 50 because we are. Let me see what we have missing in 6A to see if I am like I'm about to die or what's gonna happen. Um, okay, all right. Today might honestly be hell. I'm not gonna lie to you. It might be hell. I'm gonna be so honest with you. Okay, they're about to try to kill me. Is what's gonna happen, bro. Okay, I literally hated this part of the deck. So here we go. Photoreceptors. We can extract on that. Light is an electromagnetic wave. Yes, easy on that. There are more or less rods. There are more. Like, yeah, to be expected. We're gonna press good because I wasn't 100% sure. When a light hits a rod, the rod is turned off, which then turns on a uh uh gang. I think it's a ganglion. Maybe it's a retinal ganglion cell, which turns on a bipolar cell, which goes into uh I don't know, bro. I think something about it's gonna be something that starts with PYR. I think uh I don't know, bro. I'll be honest with you, bro. Bipolar, okay, bipolar cell, then retinal ganglion cell, then the optic nerve. Okay, okay. Um, so the light hits the rod. Light hits rod. The rod turns off. the bipolar cell turns on, retinal ganglion cell turns on. This is like the same thing as the last card, I'll be honest with you. It's the process of turning a rod cell off, the phototransduction cascade. And this, oh my god, yo, this it's like something about rhodopsin, bro. That's the problem. It's like something changing shape, like transrhodopsin, then rhodopsin, then this other random protein. I don't know, bro. Retinol, bro. Let's see. Yo, this has like 80 steps. Okay. Light hits cis retinol and converts it to trans retinol. I'm sounding like really lazy, like, but let's see. Maybe we can actually do this quickly. The steps to the phototransition cascade include light hits cisretinol and converts it to transretinol. Rhodopsin changes shape. Transducin, Okay, I'm gonna repeat this a lot. So if you guys need to like speed this up, like just feel free. Light hits cisretinol, uh, and converts it to transretinol. Okay, hold up. Let me lower this music a little bit because it's like sometimes the music gets a lot louder. I don't know why. It just like randomly gets really loud. But I'm gonna lower myself a little bit too because I'm probably like really loud. The steps to the phototransduction cascade. So light is hitting cis retinol, then the rhodopsin is gonna change and convert it to cis retinol. Transretinol. Um, I don't even know where to look in this, bro. I'm gonna be honest. I literally don't know where to look on this figure. I feel like the normal figure was much better in in Panko. Okay, so light is gonna hit cis retinol and convert it into trans retinol. And that causes rhodopsin to change shape. Rhodopsin changes shape and releases transducin, which binds to a phosphodiesterase that is gonna convert cGMP to GMP. And then because there's no cGMP, the NA channels are gonna close, and then the rod cell becomes hyperpolarized and turns off. Okay, so in the photo, okay, so I'm gonna try to explain to you guys. So in the phototransduction cascade, we have to remember that it turns off. The cell turns off because the sodium channels are always open. They're open at the beginning. So what's going to happen is we have this protein called retinol, and retinol it's cis retinol, and then when the light hits it, it makes it change into trans retinol. So the bonds are both like facing the same way, and then the light hits it, and the light and like retinol is not about that. So retinol is gonna look at it. It's gonna be like, nah, get away from me. So like the bond, it just flips. It's like fuck no. It's not dealing with that. It's not dealing with none of that. Um, with none of that stuff. So then after that, One second, guys. All right, my fault. So, um, so after retinol changes shape, then okay, I kind of cheated a little bit, but after retinol changes shape, then rhodopsin is gonna rhodopsin is gonna change shape too. Rhodopsin is rhodopsin is a little bit of a follower, so it's gonna change shape, and it's gonna release transducin. Transducin is gonna go to phosphodiesterase, and it's gonna be like, yo, we got a problem, and it's gonna start turning all the cyclic CGMP into a line, and it needs to be free flowing. Like it's not gonna. It just needs to be free and in the wild, because like the light's hitting it, like it's too much. Like when it's too hot, you don't want to be all clumped up, like that's pretty much what phosphodiesterase is sending the signal to CGMP for. It's saying, okay, you need to be free. You need to be free, not all clumped up. It's too hot for that. So it's not actually saying that, but this is the story that I'm gonna create in my head, so I remember this. So then it's gonna be like, okay, let's turn you into GMP. But the channels are like, yo, are you serious? Are you serious? Now we don't have enough to keep these channels open. The sodium channels are like, bro, we can't keep this open. Is this like a charity? You think this is a charity or something? So it's gonna close. The channels are gonna close, and then the cell's gonna become hyperpolarized, and the rod cell's gonna be turned off, and it's all because the light cell hit cis retinol, and retinol couldn't take it. Retinol couldn't take that. Wasn't trying to deal with the heat. That's why. That's why. So hopefully I remember that in the next minute when it shows up when this card shows up again. When light hits a rod, the rod is turned off, which then turns on a bipolar cell, which then turns on a retinal ganglion cell, which goes into the optic nerve and enters the brain. So the light hits the rod gets turned off, the signal turns on a retinal ganglion cell, which no, it turns on a bipolar cell, which turns on a retinal ganglion cell, which turns on the optic nerve and gets sent to the brain. Process of turning a rod cell off. Okay, I'm not taking a break. The process of turning a rod cell off. We're probably also not doing cars, guys, today. I'm not gonna lie. I would do cars, but literally this stream would end at I don't even know. It's already 3 in the morning, so which I realize is my fault. But the process of turning a rod cell off. Um, uh, so it's the phototransduction cascade. Um, when light hits a rod, um, oh, it's asking about off center versus on center. When it hits a rod, on center are active and off center. Well, I guess, well, yeah, on center are active and the off center would be inactive, right? Yeah. I don't know why I was doubting myself so much. When on center bipolar cells are turned on, this activates on center retinal ganglion cells. When it's dark, rod cells are turned on. There are there are much more rods than coils. When off center are turned on, this activates off center retinal ganglion cells. Um, this is photopic vision. This is mesopic vision. This is scotopic vision. Large membrane structures that contain proteins that fire extra potentials to the brain. Um, I don't know. Optic discs. I kind of want a brain. I'm not a bro. I want a picture of the optic discs. Don't ask me how I confuse those two. No. Optic disc. Um, picture minus blind spot. What? I've done that so much on this stream where I'm trying to copy something and I just like um okay. Honestly, the definition did not give me a better explanation, so we're just gonna remember that. Large membrane bound structures that contain proteins that fire APs to the brain. Rods have a fast recovery time. Cones have a slow recovery time. Oh, damn. So that's why you get flashbanged. You get flashbanged. Like when you get flashbanged, you don't ever see a rainbow. Yeah, you see the, you see just like a bright flash of light. That would make sense, to be honest. That's the explanation I'm gonna go with. Maybe it's not true, but that's the explanation I'm gonna go with. The steps. Okay, so basically, these are gonna be the steps. So number one, you didn't see, but I put up the number one. Then so we have cis retinol, the beginning of the problem. So cis retinol is gonna flip the direction of his hand or of his body away, and it's going to turn to transretinol. And that's going to cause rhodopsin to change shape too, because rhodopsin is a follower. And then after rhodopsin follows, then transducin gets released as a result. It's like a jail. He was holding transducin hostage, and now because he want to change shape all of a sudden, transducin is gone now too. So transducin want to leave. He gonna go tell phosphodiesterase. Then phosphodiesterase is gonna turn CGMP into GMP, and now the channels are upset. The sodium channels are gonna be upset, and they're gonna need to close because there's not enough CGMP, and it's gonna hyperpolarize the rod cell, and then it's gonna cause the cell to turn off. That's the phototransduction cascade. Well, that was actually a really good explanation. I think I got through that pretty quickly. are large membrane-bound structures, optic discs. So the light hits the rod, then the rod turns off. Um, the rod turns off. That causes the bipolar cell to turn on, retinal ganglion cell to turn on, and the signal to travel through the optic nerve to travel to the brain. I don't know how many times I really need to do this. I'll be honest with you. I feel like I should suspend one of these cards. I think I'm gonna suspend this card because how many times do I need to say the same information? Rods have a slow recovery time. Cones have a fast one. This is where the optic disc or blind spot, I guess. It's the same thing, bro. I'm gonna. There are no photoreceptors in the optic disc. There is higher resolution in the fovea because there's no blood vessels blocking it. Oh damn. Okay. Axons. There's no axons in the way of the light. Right visual field goes to the left side of the brain. Left visual field goes to the right. It hits the. Oh, this is like nasal and temporal. Okay, so this is the. It hits the like. Okay, from the left side. If it's coming from the left side, it's gonna hit your right nasal and your left temporal. Oh, wait, from the left side? Oh yeah, my left nasal. Sorry. Damn. I actually could have had that, but I have to click again now. So if it's coming from my right, it's gonna hit my right nasal and my left temporal. Optic nerves from each eyeball cross over at the optic chiasm. Right. There's higher resolution in the fovea because there's no axons in the way of light entering the cell. Axons leaving from the temporal region of the retina. From the temporal region, no, they don't cross over. Is breaking down an object into its component features. I don't know. Feature detection. The three components of feature detection include, I don't know, color, form, and motion. Blank of color vision states that there are three types of cones. The trichromatic theory. Okay. Blank is the shape and boundaries of an object form. Light from the left side hits the left nasal region, the left nasal retina, and the right temporal retina. There is high resolution in the fovea because there's no axons in the way of light entering the side. They cross over at the optic chiasm, um, the parvocellular pathway. Spatial resolution, form, high levels of detail and color. Um, I don't remember. Feature detection. Form, motion, depth. Color, form, motion. Fuck. Form. The trichromatic theory. I'm gonna add to give the percents of each type. Okay. The parvocellular pathway has good spatial resolution, but poor temporal. Okay. Parvocellular relies on cones, clearly. When light hits a rod on center, off center, is good at parvocellular. Good at determining, I don't know, motion and depth. Length is breaking down an object into its component. Feature detection, the components, so form, color, motion. Okay, so cis retinol goes from cis retinol to trans retinol. Then rhodopsin changes shape, releases transducin. Transducin activates phosphodiesterase. Phosphodiesterase turns CGMP to GMP. There's low CGMP, so the NA channels close. Hyperpolarize the cell turns off. The rod cell turns off. The trichromatic theory, and its RGB is 60-30-10. Um, Optic discs. It has good spatial resolution, but poor temporal resolution. When it's dark, rod cells are turned. Um, Dark rod cells are turned. Off. No, they're turned on. Sorry. Good at determining motion and depth. Feature detection. Um, Form, motion, and I want to say depth, Loki. Bro, color, form, motion. Ugh. On center are turned on. This activates on center retinal ganglion cells. It has good temporal resolution, but bad spatial resolution. It relies on rods. It's focusing all information at the same time, parallel processing. Our sense of sound, audition. To hear a sound, you need like it's gonna say that I think like hair cells and a tympanic membrane. Oh damn. Pressurized sound waves and hair cells. Damn. Light from the right side is gonna hit your right nasal and left temporal retina. I think long wavelength, right? Long wavelength. Long wavelength is gonna have short frequency. So maybe that's wrong. Maybe short wavelength. Maybe short wavelength. Damn. So low frequency has long wavelengths. Okay. Uh, Okay. Depth? No, it's not depth. Form, motion, and color. Parallel processing. because there's no axons in the way of light entering the cell. To hear a sound, you need um, pressurized sound waves and hair cells. Light from the left side of the visual field hits the left temporal retina and the right nasal. Wait, no. From the left side hits left nasal and right temporal. The outer part of the ear. This is like the pinna, I think. Yes. Sound from the pinna get funneled into the ear canal. I don't know what it's called. Auditory canal, aka external auditory meatus. Okay. The auditory canal, aka the external auditory meatus. Okay, so long wavelength sound waves. So light hits the rod turns off, bipolar cells get turned on, retinal ganglion cells get turned on, the signal travels through the optic nerve to get to the brain. Rods have a slow recovery time. Form, color, and motion. Optic disc. It's gonna hit the tympanic membrane, aka the eardrum. Eardrum vibrations will cause uh, the ossicles. There are no photoreceptors in the blind spot. In order of vibration, the ossicles include the malleus, the stapes. I think there's one more. The incus. So the malleus, the incus, and the stapes. Sound waves get funneled into the auditory canal or the external auditory meatus. The malleus is the hammer. The incus is the anvil. When it is dark, rod cells are turned off. This turned on. This inactivates. Yeah. When off-center bipolar cells are turned, what? Off-center. This activates off-center. Off. I mean on. The eardrum vibrations will cause the malleus. Oh damn. The parvocellular is good at. Damn, I need to get through these. These really. He's good at color, high levels of detail, and spatial resolution. Okay, I just forgot about form, but I actually got a good amount of that. Magnocellular. Ossicles include the malleus, aka the hammer, the incus, aka the anvil, and the stapes, aka the stirrup, to be converted into a neural impulse. Eardrum's vibrations will cause the what are these called again, bro? The ossicles. That's what I was thinking. Oh my god, bro. Axons leading from the temporal region do not cross over. It's good at spatial resolution, form, high levels of detail, color. Will cause the ossicles to vibrate. They cross over at the optic chiasm, the parvocellular pathway, optic discs, the trichromatic theory, and 60-30-10 RGB. relies on cones, long wavelength, is breaking down an object into its component features, feature detection. So cisretinol to transretinol. Then rhodopsin changes shape, releases transducin. Transducin goes and activates phosphodiesterase. Phosphodiesterase turns CGMP into GMP. Then low CGMP levels cause the Na plus channels to close, hyperpolarize the cell, and the cell turns off. Magnocellular pathway relies on rods funneled into the auditory canal or the external auditory meatus. It has good spatial resolution, poor tempo, audition. Is good at determining uh, depth and motion. Is good at spatial resolution, form, high level detail, and color. Uh, Magnocellular has good temporal resolution, bad spatial. Parallel processing. Right side hits right nasal, left temporal. You need hair cells and pressurized sound waves. Form, color, motion. There's no axons in the way of light entering the cell. Is the outer part of the ear the pinna? From the left side hits the left nasal and the right temporal retinas. Sound waves that pass through the auditory canal will hit the um, pass through the auditory canal will hit um, the tympanic membrane of the eardrum. Off-center bipolar cells are turned on. When it is dark, rod cells are turned on. This inactivates. Incus is the anvil. Malleus is the hammer. Neural into a neural impulse. Long, short wavelength. Sound waves penetrate long. Ossicles include the malleus, incus, and stapes. Eardrums vibration will cause the uh, will cause what to vibrate? Oh, the ossicles from the pinna get funneled into the auditory canal or the external auditory meatus. The magnocellular pathway form uh, spatial resolution, high levels of detail, and color. Wow, spectacular, bro. We did our 50. We did our 50, 3:32. Honestly, that's not terrible time. It took us apparently 59 minutes, I think. Well, I guess we can just check how long we've been on stream. Wow, an hour. That's pretty good, honestly. Like, I thought that we were taking a lot longer. It felt like we were taking a long time. But honestly, we did that. I'm proud of us for the day. Um, I think we're not going to be doing cars today. Um, as long as we hit our 50, we did our reviews. That is that's all. At least that's what's required of us. We have to do 75 cards at least for 4 days out of this week. So 4 days out of the six. Today is like the second day. Today will be the second day that I don't do it. So I want to make sure that I'm caught back up. I'm back on pace soon. So I just need to do like two. I just need to do the next 2 days, 75 cards. I'm hoping that that's not too difficult tomorrow. I think tomorrow should be better. But yeah, thank you to everyone who is watching, and I'll see you again tomorrow. Bye.